Hi, welcome to Physics Teacher, the channel that prepares you for the Waterloo Math and Science Contest. This is a grade 8 math Gauss contest question, and it says for this square, where C is the center of the square, what does the length of ZQ need to be so that the areas of the shaded regions are identical to the area of the non-shaded regions? Give it a try, and I'll be right back with the solution. Alright, first thing we're going to do is try to figure out as much of the dimensions as we can. So WS is 53 and XR is 40, that much we know. And we also know that the squared has side lengths of 60. That means if this entire length of 60, SR is 60, and XR is 40, then that would mean that SX must be 20 in order to add to 60. Similarly, we can say that PW is 7. Now, QY and YR are the same lengths. And since the side length is 60, that means they must each be 30. Similarly, since C is the center of our squared, going from the center to the center of any side, that length would also be 30. So CY is also 30. And that's as much as we know. So what I'm going to do now is I'm going to create a straight line connecting S and Q. And if I do that, if we look at the shaded regions, we realize that this quadrilateral, WSXC, is composed of two triangles. So let's try and look at that quadrilateral. So WSXC is composed of triangle, first of all, SXC, SXC, and another triangle, WSC. And we can figure out the area of both those triangles. So first SXC, so that has a height. We know what that height is. It's going to be 30. And so our area is 1/2 the base, which would be 20, times the height, which would be 30. And then we're going to add the area of this triangle. Now if we look at the base as being WS, that means this would be the height, which would also be 30. So that's plus 1/2 base, which is 53, times the height, which is 30. And that gives us a total area of 1095. Alright, let's do the same thing for this other shaded quadrilateral, ZC, Y, and Q, right here. We can split that up into two triangles. So the first triangle would be ZCQ, and the next triangle would be QCY. So the area of ZCQ, well, again, we know the height. That's just going to be 30. But the base is ZQ. That's what I don't know. That's what I'm looking for. So it's going to equal 1/2 ZQ times 30 plus, well, let's look at the triangle QCY. So that has a height of 30 and a base of 30. So it is 1/2 30 times 30. So this is going to give us 15 ZQ, whatever ZQ is, plus 450. Now, this whole quadrilateral square, PSRQ, since it has side length 60, we can say the area of this whole squared is just going to be lengths times widths, or 60 times 60, and that's going to give us 3,600. Now, if the areas of the shaded regions are equal to the area of the non-shaded regions, then they would each compose half of this. So, the area of the shaded regions would then be half of this, which is 1,800. And similarly, the area of the non-shaded regions would also be 1800. Well, we've already calculated the area of the shaded regions. It's this plus this. So that total area then is 1095 plus 450 plus 15 ZQ must equal 1800. Alright, so now we have our equation that we can solve for ZQ. So we'll have 15 ZQ equals 1800, and we'll bring these two terms over to the other side by subtracting them from both sides. So minus 1095 minus 450. And that is going to equal 255. Now we can divide both sides by 15, and we get ZQ equal to 255 divided by 15, which is equal to 17. Our answer is E.